Hello students, now in the continuation of differential equations, we are now today will be dealing with the homogeneous equations. So we have a separate methodology for solving the homogeneous kinds of linear equation, homogeneous differential equations. So let us see this, how we solve this question. But before to that, we have to understand actually what is homogeneous. So homogeneous, basically you have the forms dy by dx. So it would be like say dy by dx, and then on the right side you will have the form y upon x, and it may be dx by dy also, when we have to put the right side of the given differential equation in the form of x upon y. So all the variables can be transformed into either y by x or x by y. If it is dx by dy, then x by y, and if dy by dx, then y by x. So, and then if the constants are there, that's okay, no problem. So here we have the substitution, y is equal to vx, and here the substitution x is equal to vy. So now if you differentiate both sides, then what will happen? Dy by dx is equal to v plus x dv by dx. And in this case, if you differentiate both sides, so here dx by dy, because both sides we are differentiating with respect to y in this case. So differentiating with respect to here x, and here differentiating with respect to y. So dx by dy will be equal to v plus y dv by dy. So these important substitutions we have to make in place of dy by dx and dx by dy. Then why are we doing this? This is very important. Why are we doing this? Because in a normal way the variables are implicit. The function is implicit. X and y are intertwined in such a way that we can't separate them. So that's how we have the this method at place, that is called homogeneous. So this is basically homogeneous. So let's do the question, and then we will understand its methodology. So we are given here x square dy by dx, and then on the right side we have. So if you divide both sides with x square, then you have dy by dx is nothing but 1 plus y by x plus y upon x whole square. Now this is somewhat in the same form I was just now telling you. Dy by dx is in the form of y by x. Here this is y by x, this is y by x whole square, and one is it is just constant, so constant doesn't make any difference. So it is in homogeneous form. So what is to be done here? That is very important. What to do? Like we will assume y is equal to vx. Actually we are going to eliminate y here by this substitution, and then the variable that we will have, a new variable, that is v. So y will be vanishing and v will come out. So you have now two variables, x and v. They are variables separable, so we can separate them, we can integrate them, and that's how we are finding the differential equations, solution of the differential equation. So here, as I said, we have to assume let y is equal to vx. So differentiate both sides with respect to x. What will happen here? Dy by dx is equal to, it will be v plus x dv by dx. So this substitution we have to make in place of this, and in place of since we have assumed y is equal to vx, so this implies that y upon x is equal to v. So this also can be substituted, this with v and this is also with v. So actually what will happen? Dy by dx is nothing but v plus x dv by dx is equal to 1 plus and then v plus v square. Let's cross check. 1 is here, 1 in place of dy by dx, this substitution we have made. Y upon x is v and then y upon x whole square is v square. So 1 plus v square. So if you see here, v and v is cancelled both sides. We are left with x times dv by dx is equal to 1 plus v square. And if you arrange it, so dv upon 1 plus v square is equal to dx upon x. Now the next step is to integrate both sides. And if the integration is done, and it's very simple, it can be tan inverse v is equal to, it will be log x plus c, and it depends also because it depends what we are actually putting in here. So the next step, we have to return the value of v. So value of v is nothing but y by x. So it will be tan inverse y upon x is equal to log x plus c. So this is the general solution of the given differential equation. Now moving to the next here, this question we will try and we will see how this is also based on the homogeneous form. So here dy by dx we can write as x square plus 3y squared upon 2xy so here dy by dx is equal to, if you actually divide the numerator and denominator by x square, then what will happen? It will be 1 plus 3 times y upon x whole square upon 2 times y upon x. So what we found here, that on the right side x and y variables are there and they can be arranged in a systematic way, y over x. So now this is in homogeneous form. This is in homogeneous form. This is in homogeneous. So what will happen here? Dy by dx is equal to, if we would want this substitution, as I said, then we have to let we can put y is equal to vx, and as I said, we have to differentiate both sides with respect to x. So if you are differentiating with respect to x, so dy by dx will be equal to v plus x dv by dx, and this substitution we have to make here, and also for this y upon x will be equal to v. So actually what will happen here, 1 plus 3v square upon 2v. So 1 plus 3v square upon 2v, and on the left side we know dy by dx, so it is a v plus x dv by dx. Let's just cross check it. It's 1 plus 3v square upon 2v. So what we will do, we will go right side, so x times dv by dx is equal to 1 plus 3v squared upon 2v minus v. So if you take the LCM here, so 1 plus 3v square minus 2v square upon 2v, and here x times dv upon dx. So it will be 2v times dv upon 1 plus v square, and here right side is dx upon x. Now it's quite easy. Here it would be dx upon x. Now we need to integrate both sides. So integration is quite easy here. We can write here log 1 plus v square, and this will be equal to log x plus, we can write here log c. Why we are putting log c? Because both the terms, left hand side and right hand side in log, that's why we can take constant also in terms of c here. So now we have to return the value of v. So log 1 plus y square upon x square is equal to log of cx, because we know the formula, that is log x plus log y is equal to log x times y. So we are going to use this. Now next step would be log x square plus y square, and here it would be minus of log x square is equal to log cx, basically cx. So log x square plus y square is equal to log x square plus log cx, and next step is log x square plus y square is equal to log of cx cube. Why? Because x square and cx will be again multiplying together. We can cancel log both sides. So here x square plus y square would be equal to c times x cube. So this is nothing but the general solution of the given differential equation. So this is how we also seen the next question. Now moving to the next part, here also one more homogeneous based differential equation. So let's solve this. So here we are given dy by dx is equal to x plus y upon x minus y. So in this case, as we know, on the right hand side, if you divide numerator and denominator with x, you will get 1 plus y upon x, the denominator 1 minus y upon x, and then further substitution. So it would be dy by dx is equal to 1 plus y upon x, 1 minus y upon x, and this is completely in the form of homogeneous. So if you do the substitution here, so v plus x dv by dx is equal to 1 plus v upon 1 minus v, and the next step, x times dv by dx is equal to 1 plus v upon 1 minus v. So that would be equal to 1 plus v minus v plus v square upon 1 minus v. Now v and v got cancelled. So the next step would be 1 minus v times dv upon 1 plus v square is equal to dx upon x, and now we have to integrate both sides. So here what we can see is we can segregate it. So if you segregate it, it would be how much? 1 upon 1 plus v square dv, then minus, then v upon 1 plus v square dv, and this will be written in the substitution. If you do differentiation of 1 plus v square, 1 is 0, v square 2v, so we keep it here 2, and here to neutralize it 1 upon v we can write, and on the right hand side we can write here nothing but log x, and plus c we will write, so we can write log x plus c. So now the next and the last, you can say, we can write here is tan inverse v. So it is nothing but, it would be tan inverse v, so we can simply write here tan inverse v, and next here half times, negative half times log 1 plus v square, So minus half times it will be log 1 plus v square is equal to, and here log x plus c. So log x plus c is there. So now we have to see one thing here, like what is the value of v? We are going to return the value of v. So it would be tan inverse y upon x minus 1 half log, it would be x square plus y square upon x square is equal to log x plus. So it's better, if we want we can write in place of a c, we can write here log c also. So let it be log c. In the previous slide also let it be log c itself. So this is log c. So let it be log c here. So the next step would be tan inverse y upon x minus half log x square plus y square, and then it would be how much? Minus minus plus half log x square is equal to log x plus log c. So the next step would be tan inverse y upon x minus half times x square, it will be here log x square plus y square, and this portion will get cancelled because this is square root of this x and x, both are same here. So it will come this side, and we can go accordingly. Nothing is left here, so you can write here log c. So here we can write here tan inverse y upon x is equal to log c plus log, and then it would be root under x square plus y square. And if you want both sides log, then we can write this way also, log e base e then e raised to the power tan inverse y by x is equal to log c times root under x square plus y square, c times root under x square plus y square. Now log is getting cancelled both sides, so the final result would be e raised to the power tan inverse y by x is equal to c times root under x square plus y square. So this is the general solution of the given differential equation. Now let's talk about this one, but just to see how can it be solved. This is again the form of homogeneous. So how will we solve? Dy by dx is equal to, it can be written as x upon y plus 1. So the next step would be v plus x dv by dx is equal to v plus 1. Now we can cancel both sides. So here dv will be equal to dx upon x, and now we will integrate. So v is equal to log x plus c. So v is nothing but y by x. So y by x is equal to log x plus c. So this is again the general solution of the given differential equation. Now moving to the next, let's talk about this one also. So how will you solve it? We will put firstly dy by dx, and that can be written as x square plus y square upon x square plus xy. So we can do one thing, we can divide the numerator and denominator by x square. So next step would be dy by dx is equal to 1 plus y upon x whole square upon 1 plus y upon x. So now we will go for the substitution. So v plus x dv by dx is equal to 1 plus v square upon 1 plus v. Now we will take the next step. So x times dv by dx is equal to 1 plus v square upon 1 plus v minus v. So x dv by dx is equal to 1 plus v square minus v square upon 1 plus v. So here v square and v square got cancelled. So it would be 1 plus v times dv upon 1 minus v, and then this will be dx upon x. So we can do this. 1 plus v upon 1 minus v is equal to 2 upon 1 minus v minus 1. In this case, what will happen? The LCM can be written as 1 minus v. So 2 minus 1 plus v. So 2 minus 1 is 1. So 1 plus v upon 1 minus v. So this substitution we can make it here, and we will get the integration of this. So finally, we can do this. So the next step here is 2 upon 1 minus v dv minus 1 dv is equal to log x plus c. So if you subtract this, it will be 1 minus 1 minus minus plus. So the next step would be minus 2 log 1 minus v minus v is equal to log x plus c. So now we have to substitute the value. So minus 2 times log 1 minus y upon x minus y upon x is equal to log x plus c. So this is the required general solution of the given differential equation. So this is done. Now let me check if we have some more homogeneous. So let's do this question. This is basically asking for the particular solution. So in this, how will you solve? First of all, we will go via general solution. Then after, at the end, we will put the value of x and y, and then we will get by returning the value of c. So here dy by dx can be written as y minus x upon x plus y. So if it goes that side, so dy by dx and then y minus x. So the next step would be to neutralize this so that it will be in homogeneous form. So dy by dx is equal to y by x minus 1 upon 1 plus y by x. Next step will be v plus x dv by dx is equal to, we can write v minus 1 upon v plus 1. And the next step is v plus x dv by dx is equal to v minus, actually we don't want this v this side, so we can write x dv by dx is equal to v minus 1 upon v plus 1 minus v. So if you take LCM, it would be v plus 1, and here v minus 1 minus v square minus v. So here v and v got cancelled. Now the next step would be x dv by dx is equal to x dv by dx is equal to it's a negative of it is 1 plus v square, 1 plus v square upon 1 plus v, or we can write this way. So next step would be 1 plus v times dv upon 1 plus v square is equal to dx upon x. Now the next step is to integrate once we have separated the variables. So here all the substitutions already I have done, same method. So in fact here we have substituted in place of y vx. So basically dy by dx became x v, and we have differentiated it. So this can be written as 1 over 1 plus v square dv plus integral of v upon 1 plus v square dv is equal to log x plus c. Now we go for substitution. So integral of differentiation of 1 plus v square is 2v. So we can neutralize it here with writing 1 over 2. Now what is the integration of this? The integration will be tan inverse v. So it would be tan inverse v, and then 1 by 2 log 1 plus v square, 1 by 2 log 1 plus v square is equal to log x plus c. So if you see it very clearly, what we are finding here, it's a tan inverse, this is tan inverse v, and this is half plus half times log 1 plus v square is equal to log x plus c. So now we have to return the value of v. So tan inverse y upon x plus half times log, it would be how much? X square plus y square upon x square is equal to log x plus c. Now if you open it, then it would be tan inverse y upon x plus half times log x square plus y square, then minus it will be there. So minus half log x, literally, because root of x square is equal to log x plus c. So it will be 2 log x. Finally tan inverse y upon x plus half times log x square plus y square is equal to 2 times of log x plus c. This is nothing but the general solution of the given differential equation. Now we want the particular solution, because the value of x and y is given, x is 1 and y is 1. So with this we can get the value of c. So it would be tan inverse 1, that is nothing but pi by 4, and this is 1 plus 1 2. So it will be plus 1 by 2 log 2, and then is equal to 2 log 1 plus c. Log 1 is nothing but 0. So this portion will become 0. So ultimately we got this value of c is pi by 4 plus half times log 2. So we can put in there. So particular solution will be tan inverse y upon x plus half times log x square plus y square is equal to 2 log x plus pi by 4 plus half log 2. This is nothing but the particular solution of the given differential equation. So now let's see if we have, no, so we are done with homogeneous now. So this is the end of this session. In the next session, we will be dealing with the linear form of differential equation. And then we will take some questions based on the previous year asked in IIT JEE Main and Advanced. So thank you all of you. Thank you very much.